right, so I should probably unfreeze that screen, eh? Okay, looking. Ooh, control. Oh, it's right there. Okay, homework last night. What were our problems? Which numbers? Okay, well, we can look at those. Okay, did you guys use the solutions manual that I posted? Yeah. Okay, don't forget I posted the solutions manual that has all the odds and all the evens, or just the odds? I think it's all of them. Yeah. I'm pretty sure it's all of them. Okay, with the last important, I'm just going to always repeat this. If you're just copying, you're not learning. Come talk to me if you're having issues. Okay, 35. Looking at this thing, you better have factored it, and I have a feeling you're going to get 4. The limit on 35 is 4. And they're all odds, right? Okay. This one, let's see, it's x times x minus 1. So -1 times negative must be 2. Okay. And I can quit doing them. I have the answers here. 39 should be 2. Okay. 41, what'd you get? 1 over 2 root 2. And if we rationalize that, it'd be root 2 over 4. I'm okay with that. Yep, I'm good. Okay, 43. Can you do that one first? Sure. Okay, I'm stuck already. Man, what's the first thing I should try? Oh, gosh darn it, it makes me divide by 0 when I do direct substitution because of that pesky x minus 4. Well, can you guys factor that, you think? I can't factor. I mean, might be able to factor it, but certainly not going to factor nicely. If only there were another approach that one could take here. Wholly rationalizing the numerator. So let's take a look. Okay, here I am, and let's just see what shakes out. What do you want me to multiply by if I'm trying to rationalize the numerator? One more time. Which one are we doing? Son of a gun. Yeah, we just read 41 as, yeah, that's the over root 2 discussion. Root 2 over 4 or 1 over root 2? 2 over root 2. I don't remember which one it was. So we are doing 43, right? Okay. Okay. What do I multiply by? Plus 3 over itself. Okay. Now, I am always going to try to take the easiest possible path when it's given. I think this is going to be the easiest possible path. Am I going to actually distribute and FOIL out the denominator? Not a chance, Lance. Okay, so let's look. The limit as x approaches 4. The numerator becomes nice, I think. What's the numerator turn into? X plus 5 minus 9. Can everybody see that this becomes x plus 5 minus 9? So if we do this, that's squaring it. The roots are gone. And then we add 3 times that root and subtract 3 times that root, so they fall out. And every time this will happen, this is why the conjugate is so valuable. When we FOIL this, it's just the first term squared minus the second term squared. Every time. Every single time. Because this is a difference of squares that we're using. Okay, which means I would have x plus 5 minus 9. But I'm going to go one step further. X plus 5 minus 9 is really just x minus 4. So this is my simplified numerator. All over x minus 4 times x plus 1 times root x plus 5 plus 3. Okay, resist the urge to do too much. What happens? It's really convenient. They divide out. What's in the numerator? 1. We now have a different function that agrees at every single place except 4. What should I try now that we essentially have a new limit? All right, let's do it. I get 1 over, what's 4 plus 1? And what's the square root of 9? Because that's 4 plus 5, it's 9. Plus 3? What do you think this limit is? 1/30th, and we're correct. You just plugged in, right? For once I'm here, yep, this is direct sub. Like, as soon as you see me quit writing the limit sign, pretty good chance it's direct sub. And by pretty good chance, I mean it's direct sub. Right here? What are we plugging in for x? 4. So check it out. This becomes 1 over, and we'll just plug it in, 4 plus 1, and the square root of 4 plus 5 plus 3. What's this number? What's this become the square root of? Ooh.
Whoa, why did I think 20? Okay, multiply.
Yep. Okay, I see where your mistake. Yep. Okay. Cool. All right. 43. Might have been the hardest one. I don't know. How far do we go? I need to look at the up through 47. Okay, 45. Okay, the one-sided limit. It says using the properties of limits. We could split this up, right? It's the limit of x squared minus the limit of 4. Can we just direct sub? What's 9 minus 4? In fact, it is. 45 is 5. Okay, 47. Why? What method you use? You did direct sub? You factored. Okay. And on 49, we didn't do. Okay, where after 47? 48, you had to factor 6. Okay. Where to from there? 51 through 50 what? 59. Okay. So we're just trying to find these. Love it. These ones, did they go okay? What's 51? Negative 1. Does anybody need me to explain where negative 1 comes from? Okay. So 51 is negative 1. 53 is 8. 55 is 0. 57 is 1/4. Where to next? 59, I suppose. Yeah, we can look at 59. Okay. In problems, 59, use the graphs of the functions and the properties of limits to find each limit. Okay. I will point from here because we don't have everybody. Let's check it out. Can you identify, nobody in here is colorblind, I'm pretty sure. Which one's blue? Can everybody see blue and black here? Okay. Eventually it's going to come out that somebody's not realized they were colorblind. I'm not kidding. It's going to happen. If I'm doing the limit as x approaches 4, or the limit of a sum is the what? So let's check it. If this is just going to be the limit of f plus the limit of g. Well, let's look at them. As I get really close to 4 on my function f, what y value do we get really close to? 8. Okay? So keep that in your head. It's 8. Plus, what's the limit of g as I approach 4? Where's 4? Here? Negative 2. Because I'm just on this red line. So I had 4 plus negative 2. What's that limit? Hold up. It should be, is it plus or minus? It's plus. Is it 6? It's 8. I said 6 because I looked at the point. Okay, that makes more sense. 8 plus negative 2. I'm sorry. That's where the 6 comes from. I misspoke because I looked at that point and I said 6 instead of 8. I got goofed. Cool. Okay, on Bravo. And we can probably, I'm not going to write it here, but we can probably just write some of this down. And I will write it here just in pencil. So let's take a look. What's the limit as x approaches 4 of f again? 8. So I'm just going to write that down here. We'll say that that was 8. And the limit of a product is, okay, what's the limit of g? Negative 2 minus, what's the limit of h? Okay. So what's negative 8? Sorry, 8 times negative 2 minus 0? Negative 16 it is. Okay. Yep, and it's going to happen every single time we're just using those properties. And the properties are much more valuable on the graph type situation than they are because we just direct sub if it's analytic. Okay, so we're just going to blast through these next ones. 59 Charlie is also negative 16. 59 Delta was what? 0. 59 Echo, negative 1/4. And 59 Foxtrot, 0. Cool. Was that everything? Okay, don't rip it out yet. We have a pretty quick and easy day today. We're going to finish the section. I'm going to add just a few problems to your homework. My hope is that you'll be able to finish it before you leave today. That's my goal. Okay. The book, somebody asked about the online one. I'm torn on whether I want to keep searching or not. It matches pretty well. What this book has that I'm going to constantly assign to you that the other one doesn't is the AP problems. So I can certainly post a PDF that has most of the same stuff, but I'll put that up in case you're on a trip or you forgot your book or whatever. But I would still encourage, if you don't want to take your book, you should take your book because it's full of incredibly valuable stuff. But I would just do the video thing for now. I'll keep digging around to see if we can get the digital licenses. I saved like $30,000 when we did the textbook order, so I might have a little bit of swing to get us just the digital books, which would be nice, but we'll see. Okay, we have one last little thing to look at here, and it's something that we dealt with last year, and I'm just going to throw it up on the board here. And I hate when I say that because I don't know, when I say I'm going to throw it up here, do you guys think like, blah? Because that's every time I say it, and I say throw stuff on the board all the time. I always use the phrase, I'm going to throw it up here, and it makes me think that I'm vomiting, and nobody ever gives me a second look. But now you might. Do you remember talking about this last year? We have a picture here that I can even tell you, do you guys keep your old notes and stuff?
Yes.
Okay, I'm not going to make you like dig them out and look at them, but have we ever, have we dealt with this sort of situation before? And obviously the answer is yes, just so you know, because I can remember exactly where it happened. But I'm going to try to see if we can't like dig this back from memory. And we're going to see a really important idea that we just get to take one step further than we did last year. Forget about the axes right here. Do you agree that if we just wanted to, we could say, hey, this is some x value right here? Okay. Now, if I went some distance over, let's say I started here, and I just went, I don't know, to say this point, and I just said, hey, I went h units. Can you tell me what, if that's x, what would this x value right here have to be? X plus h says Karina. Do you guys agree with that? Okay. So let's just see this. And you don't have to draw this big picture. I will help you draw the nicer picture here shortly. But this would just be x plus h right here. Okay. Now, if I looked at this, what's this y value? And again, I'll get rid of my scale. Just I should have done it without a scale. But if this is x, what's this y value? And I guess we don't have a name for our function. Let's say we have our red function is f. This is just f of x, right? What's this y value all the way up here, straight above that other one? F of x plus h. Now, if we're looking at this, and I started with the parabola. I just have this other piece on here. Well, if I start with the parabola, I can find this green line. And I've drawn a secant line here, is what I've done. If I asked how fast does that green line change, could you tell me? Could we calculate it out? How fast does that green line change? Like, and I'm trying to avoid a specific word because the second I say the word, you're going to know it. It's the rate of change or the slope. Now, I could find the slope between those 2 points, especially if I gave you an x value and you picked some h. Okay, what we're going to see right now is like the beauty of calculus. What we have on the board currently is a rate of change, right? It's a slope. Okay, where we're going, and it's not fully what we're doing today, but this is awesome. If I said, hey, at this point on that red graph, how quickly is it changing? Or what is the slope of the red graph? That's a weird question because when we talk about slope, we talk lines. And that green graph is certainly not a line. Or sorry, the red one's not a line. It's a curve. Okay, so it's already kind of a weird question. But is this a really good approximation? Do you think the slope of this green line is the same as the slope of the red line right here? Do you think that the slope of the green line would be the slope, like, if I look at the red one, am I increasing or decreasing as I work? Decreasing, so it's a negative rate of change. Do we agree with that? Okay, this green line that I'm trying to use to estimate it, does it have a negative or positive rate of change? Positive. Do we agree that they're way different? Now, that's because on this graph that I see here, the h that I gave was like 4.5. It was pretty big. Could we make that h change smaller? Like, instead of going all the way over here, if I go to here, it's a little less. Does it? It's still not very matching, but do you think it's closer to the actual rate of change? As I start making h smaller and smaller and smaller, does the rate of change or the slope of that green line start to look a little or a lot, either one, however you want to word it, more like the actual change of that function? As I get closer and closer and closer, would you agree that right there, that's pretty much right on? Okay, what happened with h? So like here I have h is 3, right? And it's a terrible approximation, and I'm saying 3 because I'm going from 1 to 4. Terrible. Does it get better as h goes, instead of 3, it's 2? Is that closer to the actual slope? And as h is only a distance of 1, does it get even closer? How close can I get? How small of a change horizontally can I make h so that my approximation is super good? It can't quite become truly 0 because it wouldn't work, right? But can it get arbitrarily close to 0? Well, have we seen an idea in Calc where we get arbitrarily close to some value? What's that called? The limit. Okay. Now, what we're looking at here is a secant line. And we're going to sneak this in, and I promise it'll all tie back to this. You do not need this big picture in your graph today, but we will. The last little piece of 1.2, yeah, is our focus on the limit of average rates of change. If you have a shorthand that you know and you don't want to write average rates of change right now, you're good. I'm going to write it one time. Of change. What's the shorthand for average rate of change? AROC is what I use. I use the lowercase o so I don't forget it's the of change. But if you want to use ARC, I'm okay with it, but an arc is a thing in math already. Okay, so check it out. To find the slope of a secant line, and that's essentially what we did. If you give me a function f of x and some distance away from that x value that we pick, we get the slope of a secant line. So we'll just go ahead and say slope of secant line given by, and let's say we have this following lovely expression. We're just going to say it's f of b minus f of a, like it's a regular old expression. F of b minus f of a over what? I'll let you guys catch up because I know I talk too fast. It's just over b minus a, right? Now, if we're looking at these things, maybe, just maybe, we can use this to help us out with a couple ideas. It turns out that the slope of the secant line that we are given, this is simply the interpretation of an average rate of change. So this is the average rate of change for x, and we'll use actual words, for x in the interval from what value of x to what value of x, based on what's written over here. Let me rephrase that because the silence is deafening. What are the two x values that we have in that expression up above on the slope that we have? B and A. So do you agree that we must be going from A to B? And it could be B to A, but it'd be weird to have it backward like that. It could be. Okay. This is the average rate of change. This is how we calculate it. Just pick two spots and find the slope of it. Now, I'm sure I pointed this out before, but it's always mind-blowing to me. How many of you guys woke up in your bed this morning? It'd be weird if you didn't, I think, but maybe you're staying at somebody else's house, so there's certainly situations. How many of you will go to bed in the same spot tonight? Okay. If I claim that your average speed or your average rate of change, we'll call it speed because that's what rate of change in our context is, was 0 throughout the day, does that feel natural to you? On average, you weren't moving today. That feels like nonsense, right? But check it out. If you're talking about like your speed, it's just your change in position over time. If we started the second before you woke up and that's our first measurement, and our second measurement was the second you went to sleep later that night, how far have you moved from where you started to where you ended? None. So if we had no distance changed over all day long, what was your average speed? Every day your average speed is 0. And it's bizarre that that happens. That's not to say that you're going 0 all day long, right? That doesn't make sense. Of course, you're moving throughout the day, but half the day is positive, the other half is negative, they cancel each other out. Your average rate of change is 0. As we're doing this, we're going to find the average rate of change of some function. And we're going to do this one together, and then I'm going to have you guys do an uglier one on the board, I think. Check it out. I'm standing here. Love that question. I want to walk in the positive direction. What way do I walk? Okay, so why that way, out of curiosity? Which way is positive now? Interesting. Okay. Not what I was expecting, but that's okay. I'm an x-axis. Which way is positive for you? Okay, check it out. I'm walking positive right now. Okay? And then I stop and I walk back. I did not go 0 that whole time. Do you agree? Like there was a brief second over there where I turned around where I had to go 0 because I changed direction. But if we said, hey, I started here and I ended here, those are my positions. Over however much time, have I moved from where I started? If I'm just looking at here, start and finish. So the positive is undone when I walk back. No matter how far you walk away from your bed in the morning, eventually you'll walk back to your bed, and it's just the exact opposite direction. Even if it's like a circle or whatever, like, okay, as we're looking at this, I want us to find an average rate of change. And we're going to sneak in a limit here, and we're going to make sense of it. I want, together, we're going to find the AROC for the function defined as f of x equals square root of x. And let's say from x equals 1 to x. And I know that that seems weird. We're just going from a very specific starting point from 1 to some unknown right now is what we're doing. Okay. Now, as we do this, the second little part is we are going to use the result. So there's really two parts to this. To find the limit as x approaches 1. Okay, so let's think this out. As we go through, I think I have some pieces that I can work with. If we try to think about this thing, let's just figure out where we are. We haven't, do you want a graph? We don't really have a specific graph, but we could think about it as a graph if you'd like. I'm going from 1 to where? X. Which one's bigger? Or do you know for sure which one's bigger, 1 or X? You can't really tell, right? So if we're just trying to plug this in, well, let's just see how this might shake out. I think it might be something like f of x, and we'll just call this the average rate of change. Let's just plug it into our slope. I just want to find the slope of that line that goes from 1 to x. We would have f of x minus f of what? What's the other x value that we're given? So that's the function, and we'll plug it in here in a minute. But if we're just doing this, it's like f of 1 here, or x here, and what would this one be? 1, I think, because if we're going from a to b, notice it's just b and a right here. So if we're going from 1 to x, it's just going to be x and 1. We're just putting them in the exact same spot. It's just, it looks weird because they're both x. Over what? Okay, so this is like our true expression. And now we're going to use what Red suggested. Do we know what the function is? Yeah, so let's just work out what this is going to be. This is going to be the square root of x. That's my function f of x. Minus, what's f of 1? 1. Why? How come? Explain that just in case. Yeah, square root of 1 is 1. So we get the square root of x over, or sorry, minus 1 over what? X minus 1. Okay. So graphically, if you want to include it, I'm just going to put it up on the board. What we're doing, and you don't need to have this graph, it's just might help. Here's the square root of x. And we're going from 1 to some x value. Like, I don't know where it is. Is this kind of like what we did a second ago when we did x and h? We're just using different letters. Okay. If I want this, what we have found just now is an equation that you tell me the x, and no matter where it is, I can find you the slope of this line. That's what we just did. Now, if I wanted to know how fast was it changing at one particular point, like at 1, can I imagine this point getting closer and closer over here? So that instead of having this secant line here, does it get better as we get closer to it? Just like we did in the picture. Okay, I saw a couple nods that convinced me. Is this the same thing but with a different function? Like I started at 1 and x, and now I'm just getting closer, and my slope's getting closer to what it actually is on the function, right? Okay, so same thing. I'm not going to type in the new function. I want you guys, this is a really quick review. I want you to find me the limit of this average rate of change. So I'm at the bottom of my screen. I'm going to give you guys a second. You're going to find me the limit as x approaches 1 of this, root x minus 1 over x minus 1. Okay, with your neighbors, I'm going to give you a moment to do this. If anybody wants to shout out the technique that we're going to use to solve this limit, it's fair game. Or not, apparently, but that's okay. Is this a direct sub? Why? Oh, zeros. This is a factoring problem? Oh, it's a rationalizing. Okay, so I'm going to let you guys rationalize this one real quick, and we'll meet up. Little bit of practice. Christina, do you already have a number? What do you got? Like that? Yeah. Okay. Okay, I have one suggested answer on the board. I'll wait for somebody to second this. Okay, I got a second. Can I get a 3rd through 11th? Thanks, Red. Okay, we'll go about 10 more seconds. You do not have to rationalize. You should not rationalize. What did you multiply by?
That's what I got to. Wait, what was the answer they said?
1 over the square root of x plus 1.
Oh, that's what I did, but then I plugged in 1 in. Do I have to do that?
Ooh, do we have something to plug in? What is x approaching? Okay, so what is this really? 1/2. Okay, the slope is 1/2. Now, I did a really lazy sketch with this. But if we were to look, and I'll even get a better graph right here. If we were to graph the square root of x, and right here we said, hey, that slope is 1/2, would you believe it? Is it at least, without any scale, do you believe that this line has a slope of 1/2? Yeah, like it's probably closer to 1 or something bigger because I just sketched it really roughly, but it's at least kind of believable. Okay, I feel pretty good about that. Now, what's really cool is we just did a pretty big idea. Now, without going any more into detail, we just found our first derivative. That is a chapter 2 idea. You probably won't see this word again, or you will, but we won't find them explicitly. But that worked really well if I wanted the slope at 1. If I wanted to know what was the slope of this curve at 2, we would have to redo the entire problem. And if I wanted to know it at 3, we'd have to redo the entire problem. If I had to know how fast that function was changing at a bunch of different spaces or places, it'd be nice if I just had one singular thing that I could plug into, right? So check it out. Back to our pre-calc idea. This is literally the last thing that we're writing down. And maybe one more example, what I think is going to be on the board. Since we're talking about the limits and average rates of change, the last little piece is going to be the limit of a difference quotient. Now, this sounds so ugly. And do you guys remember talking difference quotients last year? You will as soon as I write it. Okay. Difference quotient sounds like it can be scary, and I don't know why the word quotient has a bad rap in my mind. It just sounds like a hard word. Quotient just means we're doing what? Dividing, which probably a fraction involved. Difference just means what? A subtraction. Did we just, if you look at the problem we just did, was there a quotient with a difference? We've already done this. Now, from pre-calc, when we present these, and when I presented them, and we only saw it very briefly, but we have our difference quotient. And I'm going to use diff quo as the shorthand. Here it is. It is just simply going to be f of x plus h minus f of x. So there's some change in y that I noticed. This is the y values, which kind of looks like what we did a second ago, divided by what? If we're finding the slope of this line, we have our y value and our y value. What goes downstairs? Y, are you sure? What if I did this? F of b minus f of a? What goes downstairs on this one if we're finding the slope of it? B minus a. If we use that same idea here, what goes underneath? X plus h minus x. What goes downstairs? H. This is your difference quotient. We did these last year, chapter 1, section 10, I'm pretty sure, or 1.9. Somewhere towards the end, they were only there for just a minute. Now, when you're evaluating these, we are now going to start taking the limits of them. And it doesn't have to do anything crazy as long as you're okay with evaluating f of x plus h. So if we take the limit of this thing, we're going to do one example where we're going to take the limit of this value, and we're going to tie it back to this picture. If this was my distance h, I'm letting h, that distance, go to what eventually? And I'll even go back to, I think I just scroll up realistically. Oh, maybe. Do it. Nope, I'm over here. Thank you guys for never loudly judging me about my inability to find stuff on the computer. You can do it silently, that's okay. there's our x. Like this is the exact same thing we wrote just now. Here's my f of x and my f of x plus h. And then if I wanted to get the slope here, what do we have to let h get really close to? So careful. X plus h gets really close to x. If I only think about h as being the horizontal distance between them, when I look at the Desmos, and this one will be nice, I start here, and I want that distance between those 2 points to get closer and closer to what? Well, now I'm below 1. What's the distance on the x-axis between this point and this point? It's a little bit, right? Like half a value right now. Do we get closer? As I get closer and closer, how close can I get these 2 points to each other? Arbitrarily close. So what's that distance h between those 2 points? It's essentially what? 0. As I get closer and closer, the distance between those points on the x-axis gets closer and closer to 0, right? And that gets my approximation to be better and better. So anytime we're doing these difference quotients, and how you'll see them right now is we're going to let the limit of that difference quotient as that distance h approached, what did we just say? 0. So let's do 1 on the board or in our notes? Okay. The notes are nice because you get to see them later. The boards are nice because they're more fun to work the problem at the board, I think. Okay, I promise we'll get into a lot of, I don't know how to word it. Okay, let's do 1. All right, so here we go. F of x, we're told, is this lovely function. It's the square root of x plus 1. Now, I just want us to find a limit. I'm going to tell us the limit, but I want to really stress that there's a few different ways that we could word this. And I'm not going to go into detail about what that means right now, but I will tell you there's a whole 3 chapters focused on this idea. We've even used it once today. It's a D word, ends with derivative. Hey, it's a derivative. Okay, we're going to find the limit as h approaches 0, and I'm going to just try to trick you here. We're going to say the difference quotient. And I should have said diff quo. I don't know why I'm writing it out. Okay. The limit stuff, I'm not really concerned about you making mistakes with. The only thing that I think you should do regularly is take 1 extra line of work to do a little bit of scratch. This f of x is easy. I already know what it is. The h, I can write an h, no problem. This is the one part where if you're going to get goofed up on these, it's going to happen right here. So when I do these, and I would encourage you to do the same, but it's up to you, is before I even do the limit, I do 1 line of scratch work where I need to figure out what is x plus h, or f of x plus h. Now, this expression means that in my function f, anywhere that there was an x, what am I replacing it with? So timeout, we'll come back to it. If this is f, what's f of 4?
3.
How on earth did you get 3?
4. 4 is 2.
Okay, so I agree with you. What did you plug in for the x? Here, 4. So it's a 3. What if I did f of 9? What are you going to plug in for x? 9. What if I did f of a? What are you going to plug in for x? A. What if I just called it x plus h? We are just going to plug in x plus h anywhere that there is an x. Now, this one was not crazy. There was not a ton of scratch work needed on it. You might be able to do that one in your head. Why I would encourage the scratch work every time is because if we considered a different function that was like x squared plus 2x, that one I probably don't want you to foil in your head because you're going to have to do x plus h squared plus 2 times x. Like there's going to be more scratch work with it. I would always start with that scratch work just to make sure we get it. Now that we have f of x plus h, let's actually do our limit. We're finding the limit as h approaches what? 0. And we'll say from the right, although it doesn't necessarily have to be from the right here, just so you guys are aware. But we will say from the right. And we're doing f of x plus h minus f of x all over h. What was f of x plus h? Root x plus h plus 1. So there's my f of x. And I'll even just highlight them. Here's f of x plus h, I'm sorry. And what do I subtract from that according to my difference quotient? Just the square root of x. Now, I'm going to make a terrible mistake on the way I write this. And I've already made it. Parentheses. Okay, we'll do the parentheses this time. Normally when I do these, I just distribute the negative on this line right here. Okay, all over what? H. Okay, Now, just so it doesn't get too muddled in here, I'm going to erase that just so it doesn't like confuse me as we're looking at it. Okay. We have a limit in front of us. Davian, what's the first thing you want to try? Okay, it fails. How do I know that immediately? That pesky divide by h, or divide by 0 when we plug it in. Okay, so it means we get to do a little bit of work, which is fun because who wants a problem that solves itself? Yeah, nobody. Good. All right, so here we are. Should we clean it up a little bit, you think? Okay, so how would you have me clean this up? It's the limit as h approaches 0. And Casey, help me clean it up. What would you do to the numerator? Would this change at all? So I'm going to jump ahead a little bit because I think that question might be oddly worded. Where am I concerned about people making mistakes here? Can you guys guess? So maybe a little bit here. I'm going to be honest, though. I'm way more concerned about you not catching these parentheses. I think that's going to be a much more common mistake. When I make sure I get those parentheses, I subtract root x, and then what else? Minus 1. All over h. Krina, does anything convenient happen when we do that? The ones. Oh. Plus 1. Minus. Okay, yeah, they're gone. Now, at this point, I wouldn't normally rewrite it. It's up to you if you want to. Can we do this limit yet? Well, what's the first thing we would try again? So I love that that's what I heard. I was expecting somebody to say direct sub, but we haven't changed it. We've just cleaned it up. But Red looks at this new limit that we have in front of us, and he says, hey, direct sub still won't work, but I think that we can do some rationalizing. Do you guys agree with that? Okay, well, let's rationalize this bad boy. What do I multiply by Baija? Root x plus h plus root x. That. Yep, I got you. Okay. It's going to look like it's not helping, but it will help literally every time. Do we have to do a big hardcore FOIL and write it all out? This is the difference of squares. Every time conjugates do that. What does the numerator become, Dolan? Love it. We have these two multiplied to be x plus h. I'll make that there, x plus h. And then we have minus x all over h still. Can we tell that this is working and giving me like a nicer and nicer answer? Somebody said and I see some faces going maybe not. Whoever said it I just couldn't tell. What's nice about this? So when you say cancel, this is my concern. What do they do? What's h over h? Okay, so when we clean all this up, like everything just kind of falls out, right?
What about the other stuff disappeared?
Time out. Oh, what about the other stuff? Nothing, of course. Thank you for that. I'd like to say that was on purpose. So I will. That was on purpose. Okay. So I think the numerator is still really nice and everything else still happens, but I still have the issue with cancel. What's in the numerator still? There's still a 1. Okay. At this point, we have a new function that is no longer has an issue at that h value. Can we evaluate this limit now? What am I going to let, how do I evaluate this limit? 1 over, and do you want me to rewrite this without the scribbles? Okay. It's the limit as h approaches 0 of 1 over the square root of x plus h plus root x. Like that's everything that was left inside. What should I try when I evaluate this limit? Well, let's try it. If h goes to 0, what happens to my numerator? It's still there, right? There's no x or h in it. Okay, so it's still that. What happens to this term right here if h goes to 0? It's just root x plus root x. What is that? Okay. What we...
How did you get that?
Okay. Which, are you okay with this one here? Where I just rewrote it with the stuff that had, okay. What is h going to? Let's do x sub. What's x plus 0? Root x plus 0. You agree it's just root x? Plus, what happens to this one as h goes to 0? Not x, h. Okay. What we have in front of us, and I lied, I'm going to use the word again, we have a derivative. But we have a better derivative. Instead of just saying, how fast does this function change at some specific x value, which is what we did in that first problem, the average rate of change, we're now saying, hey, for this function, if you give me any x value, I can tell you how fast it's changing on this graph. This is a big, 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 big idea. So big that it's all of our first semester. Okay, you may not understand all the conceptual stuff happening behind the scenes, but that's okay. Doing the math, is that limit really any harder? No, it's a little ugly, but it's no harder. Every function that you guys deal with today will be this flavor. Cool. All right, so you guys have 12 minutes. I'm gonna give you some time to work on stuff. And that went a little longer. I don't know that we're gonna be able to finish it. Do you have a question, Lay? Lay, I didn't call on you today. Yeah. I got you tomorrow, all day, okay? Every question. Okay, you are going to add tonight. I'm probably kidding. You are going to add to your homework 1.2. Oh, you've already knocked out a bunch of it. You might finish this before you leave. I want you to do 48. Psych. I'm looking at the wrong part. I'm sorry. Okay. 63. 67. 73. 79. AP. And I'm going to do them like this. Everybody understand the dumb thing I'm doing there? Yeah. Okay. It does not say odds. I think that is the implication. I got you. Don't worry. I don't know. I can tell you in a second. 22. There's 8 of them. I did, but I was lying. Okay. If you didn't catch what somebody else had said, check it out. Here I am on the Google Classroom. I just scroll down just a skosh. Check it out. Chapter 1, Solutions Manual. If you haven't looked at this yet, they have not only the answers, but their work. It's not annotated really, really clearly, just so you, like, you'll see it when you look.
I looked at it last night, and it helped me. Like, I kind of looked at it for a second, like, what are they doing? And then it helped.
Yeah, the other thing, I think we're at a math level where I don't know that I would trust AI. But if you're feeling, like, do you guys use AI for various things? Whether it's academic, you guys use AI anywhere? Okay. If you're doing stuff for school, like, remember, credit it, whatever, talk with Miss Allie about how she wants if you're doing research with it. But if you guys use AI, GPT is what you use, or what do you use? Or Meta AI maybe, but check it out. The school pays for, like, our Google stuff. Google's free unless you have, like, a big business account. If you click on the waffle, we have the paid version of Gemini, which don't know what that was for, but if it's the free version of GPT where you only get so many computes, or you get unlimited Gemini of essentially the same thing, you have the Gemini and you have access to it, just so you guys know. Cool.